In this video, I'm going to give you an introduction to analytical geometry, which spans grade 10 and 11. And so the four main formulas that you will be often given, but that's worth memorizing, is gradient, which is the change in y over the change in x. If you've got 2 points, you can choose for these three formulas. You can choose which you want to be your point number 1 and point number 2. The main thing is that you just stay consistent. And the other really important thing is that you always keep your numbers in brackets when you sub them in so you don't make mistakes. So here's your gradient formula, here's your distance formula, which comes from Pythagoras, and it's the change in x squared plus the change in y squared. The midpoint is just adding the two x's and dividing by 2, adding the two y's and dividing by 2, and then tan theta equals m is always useful whenever you notice them talking about needing angles. Tan theta equals m, and use the lines that touch theta. And so sometimes at its most complex, you might get an angle that they're asking for down here. And what you'd want to do in that case is you'd want to work out the gradient of this line. You'd want to work out the gradient of this line because they both touch theta. And then if you shift, because you need an angle, if you shift tan 7, you'd get an answer very rounded off to just 82. If you shift tan -1, you'd get 135. Or if you like, you can add 180 and that will give you 45. And then how do I get theta? I would have just done vertically opposite, and you'd be able to work out your answer from there. So theta would just be 53. And so look out for that question. It's often a 4 or 5 mark question when you've got to work out theta that's in the middle of nowhere. I'm not going to cover equations of circles because we do that in the section of analytical circle geometry. Carrying on with the introduction, if you've got parallel lines, that means that they've just got the same gradient. If you've got perpendicular lines, that means that the two gradients times together will equal -1. That's the proof of it. And visually what it would look like is if the one gradient was 2/3, the other gradient perpendicular would be -3/2. So you just flip it around and change the sign. If it was 7, that's like 7/1. You flip it and change the sign. And so that's how you prove that things are perpendicular. Collinear, you see that coming up from time to time. It just means that the gradients are equal, and so you'll try work out the gradient of AB, you'll try work out the gradient of BC, and you'll see if they're equal, they're collinear. If they're not, then they're not. Always finish your work by checking visually that it makes sense. So if you've got a point, let's say you got this point D and it was -5,3, then you could see, I can see this picture is here, but my D -5 is backwards here and 3 up, it's somewhere over here. So something's wrong. Maybe I forgot to sub things in brackets. So always use the advantage of having a Cartesian plane to see if your coordinates make sense. If you need a fourth point in a parallelogram, this is a really cool trick. So let's just say we didn't have D at all, and I said the order that they say it is really important. So if they said the parallelogram A, B, C, D, because if they said A, C, B, D, then maybe D would be somewhere else. But to keep it simple, it's A, B, C, D. So all you do is you'd say, how far down did I go from this Y to all the way to -6? And to get from 2 to -6, you went 8 down. Don't worry about the sign, whether it's plus or minus, just the height change is 8. And to get from -3 to -1, the x moved 2. Then you go to your other point and you just drop a line down 8 and 2 across. So that means my x value, which is 7, I must go 2 backwards. So D would be 5. And my y value is sitting on -1. And if I went 8 up, I would end up at 7, and that's how you work out the fourth side of a parallelogram. Touches just mean that it touches once, so if you hear that word, it's often a tangent. Obtuse, you might be used to. It's between 90 and 180. Acute just means less than 90. Magnitude, that can sometimes confuse people. It just means the size of the angle. You're just working with angle. A vertice or a vertex is just the corner of a shape. And then don't forget, if you end up in analytical geometry but you have 90-degree triangles, there's a good chance that you could be working with SOHCAHTOA from trig. And so that's just a really big, broad overview of analytical geometry and where it could go in grade 10 and 11. I hope that you found that helpful. If you did, please like this video, subscribe to our channel, and share this with your friends. Thanks.